Welcome to an Achieving Science video. This video is going to look at the relative size of atoms. First of all, we have the periodic table, which as you progress through chemistry, you'll become increasingly aware of and get used to it. Here we have a list of all the elements. Each element in the periodic table has a symbol. So for instance, carbon has a symbol C. Along with this symbol, there are two numbers. One of those numbers is bigger than the other. Let's first of all begin by looking at what these numbers refer to. So let's choose an element. An everyday element that we are familiar with is oxygen. If we locate oxygen in the periodic table, we will find that it has the symbol O, and along with it has two numbers, 8 and 16. The number 8 is the atomic number, the proton number, and this indicates that oxygen has 8 protons. The larger number, the 16, is the mass number, and this is the total number of protons and neutrons. As we already know that oxygen has 8 protons, it must also have 8 neutrons, because 8 plus 8 equals 16. In fact, there are 3 subatomic particles that you need to be aware of. We've already mentioned protons, neutrons, and the third one is electrons. You also need to be able to know the differences between these subatomic particles. So an easy way to do this and record this is via a table. So let's have a look. The 3 subatomic particles are protons, neutrons, and electrons. And there are differences between them in the fact that they are found in a different place within the atom. They have different relative charges, and their relative atomic masses are different. So let's have a look. If we look at the oxygen atom and stay with this one, if we draw out the atomic structure of it, we find that at the centre of the oxygen atom we have the nucleus. Inside the nucleus we find the protons and neutrons. So inside oxygen we would find 8 protons and 8 neutrons. Around this nucleus we would find electrons. These electrons are found within shells around the nucleus. In the atom there is the same number of electrons as there are protons. So in oxygen there are 8 electrons. In this case there are 6 outer electrons, referring to oxygen being in group 6. Now if we go back to the table, we can begin to fill this in. So we can already see that protons and neutrons are found within the nucleus of the atom, and the electrons are found within shells and orbits. Now let's have a look at relative charge. Electrons are kept in orbit due to them having the opposite charge to the nucleus. Inside the nucleus there are protons and neutrons. Only protons are charged. They have a positive charge. This means therefore the electrons need to have a negative charge, the opposite charge, in order for them to be kept in orbit. In fact, the neutrons are there inside the nucleus to try and keep it stable, as the protons want to repel each other as they have the same charge and are confined to a very, very small space. Again, let's go back to the table and put in what we've now found out. We have found out that the protons have a charge of +1. We have found out that the neutrons have no charge, and the electrons have the opposite charge to protons and therefore -1. Finally, let's now have a look at the relative atomic mass. Remember, the mass number is only made up of the number of protons and neutrons. Protons and neutrons have equal mass. Notice it doesn't include electrons, as they have a negligible mass, virtually nothing. Let's go back to the table again. So, protons have a relative atomic mass of 1, neutrons have a relative atomic mass of 1, and electrons have a negligible mass. Atoms then are very small and have a radius of about 0.1 nanometers. The radius of the nucleus is less than 1 divided by 10,000th of the atom. Almost all of the mass is therefore found within the nucleus, as we said, because it is made up of protons and neutrons. Now let's look at isotopes. Some elements can have different number of neutrons and are called isotopes, e.g. carbon-12 and carbon-13. Isotopes of the same element have different physical properties, i.e. they have a different mass. They can be radioactive. Despite this difference, they have the same chemical properties. For instance, all hydrogen isotopes react with water and oxygen.